Current density. You might have studied current density in earlier classes. Here, I will just remind the concept. Suppose that we have a conductor with length L and area A. We will also assume that we have an electrons and there is a current flowing inside the conductor whose value is equal to I. If t is the time taken to traverse distance L, the total number of electrons passing through any cross-section of wire per unit time is n by t. You also know that current I is actually equal to dq divided by dt. The total charge is equal to n into q divided by t. N is the number of electrons, q is the charge on an electron, and t is the time taken for an electron to cover distance L. Assume that electrons move with a constant velocity v and velocity is given by distance traveled upon time taken. It gives us t equal to L divided by velocity. Now, replacing t, we will get current density, which is usually represented by J, is a parameter which is equal to current flowing inside the conductor per unit cross-sectional area of the conductor. Now, to find current density, we have and if you see carefully, then N upon LA is actually number of electrons divided by volume, which is nothing but concentration of electrons inside the conductor, which we will represent by small n, which will give us we got the current density to be equal to concentration of electrons inside the conductor multiplied by charge on an electron multiplied by the velocity with which electrons are moving. This is the formula for current density. Also, N into Q is sometimes referred to as rho, which is charge density, where N is the density or the concentration of electrons inside the conductor and Q is the charge on an electron.